So, hello students. Today we discuss about the very important concept, that is degree of ionization. Degree of ionization of mainly we discuss here about degree of ionization, or nothing but degree of dissociation of acids and bases. So mainly it is related. It helps to know to compare the strength of acids and the strength of different bases. We know some acids are strong, some acids are weak, some bases are strong, some bases are weak. So this can be this strength, the weak strong is known as strength of acids and bases. This can be explained with the help of the concept, that is degree of ionization or degree of dissociation. So we know that generally acid is nothing but acid means which can release more number of H plus ions. What is the base? Which can release OH minus ions. If acid dissociate more, so it releases more H plus ions. So based on that concept, we derive some formulas here. So the degree of ionization. So for example, first we see. So take a general acid. Okay. The general acid, just take A. Ha is taken as acid, and we know that there is a formation of H plus and A minus takes place. So if you take the base, we are taking a base which releases the OH minus ions, we place OH minus. So here, so the acidic character, the acidic strength mainly depends on the dissociation of acid. Means if you take HA, some amount of HA sample, if the whatever the HA is taken, if totally dissociates, means if it 100% dissociates, so there is a more number of H plus are released. For example, if you take HCl, if you take hydrochloric acid, so maximum if you take 1 mole of HCl, okay, that's for our convenience. I am taking 1 mole of HCl. 1 mole of HCl means so if it releases exactly 1 mole of H plus and 1 mole of Cl minus, so this is known as 100% dissociation. It's known as 100% dissociation. Means whatever the acid is taken, it dissociated into H plus and Cl minus. Means it did not takes place all compounds, and it is not like that. If you take 1 mole of acetic acid, if you take 1 mole of acetic acid, so here takes a very less amount. So how much amount we can't say exact value, but here we can say less than 1 mole of H plus and less than 1 mole of acetate. Means the whatever the acid taken is not dissociated totally. Okay, so means how we compare the strength of strong acids and weak acids, and the degree of dissociation means the extent of ionization. So ionization means formed into ions. Formation of ions is called ionization. Formation of ions is called ionization. So here 1 mole of HCl is become forming 1 mole of H plus and 1 mole of Cl minus. Means whatever the acid is taken, it totally dissociated. So actually not 100% takes place, generally 90 to 95% takes place. Here 1 mole of acetate, 1 mole of acetic acid does not dissociate 100%. Means the very less amounts of weak acids, very less amounts of compound is dissociates. Means maximum compound present as acetic acid only. ఇక్కడ హెచ్సిఎల్ ఎంత హెచ్సిఎల్ తీసుకున్నామో దాంట్లో మ్యాక్సిమం హెచ్సిఎల్ డిసోసియేట్ అయిపోయి హెచ్ ప్లస్ సిఎల్ మైనస్ ఫామ్ చేస్తుంది. అదే వీక్ యాసిడ్స్కి వచ్చేసరికి ఏంటంటే తీసుకున్న దాంట్లో లెస్ దెన్ 50%, వెరీ లెస్ పర్సెంటేజ్ ఈజ్ డిసోసియేటెడ్ అండ్ ఫార్మింగ్ లెస్ నెంబర్ ఆఫ్ హెచ్ ప్లస్ అండ్ రిమైనింగ్ ఈ ఎగ్జాంపుల్లో ఎసిటేట్ అయాన్స్. ఓకే, సో దట్ ఈస్ weak acid and strong acid comparison. In the same way, for base also. If a base releases more number of OH minus, and the same base could iday model explain chestam. More dissociation, more ionization, and more number of OH minus forms this, that will treat as a strong base. If it releases less number of OH minus, so automatically we can say it is a weak base. Okay, means total then by depend on the extent of ionization, means అది ఎంత పర్సెంటేజ్ ఆఫ్ కాంపౌండ్ అయోనైజ్ అవుతుంది, సో దాన్ని బేస్ చేసుకొని స్ట్రెంగ్త్ అనేది డిపెండ్ అయింది. సో నౌ వి సీ అబౌట్ ద ఎక్స్టెంట్ ఆఫ్ డిసోసియేషన్. Then we apply that concept to this equilibrium. So extent of dissociation or extent of ionization. So extent of ionization is generally denoted by alpha. So what is alpha means? So it is the ratio of number of molecules dissociated by the number of molecules taken. Okay, so for example, if you take 10 molecules iskunam, okay, 10 molecules are taken, the taken number of molecules 10, and the total 10 molecules are dissociated, then what is alpha? 10 molecules are dissociated and 10 molecules are taken, total equal to 1. Means the maximum value for alpha is 1. So extent of ionization is different, degree of ionization is different. What is the difference? At a degree of ionization is in terms of percentage. Just alpha raste, that is called only in terms of numbers. In terms of number of molecules, that is called alpha. That is also known as extent of ionization. How you write the formula? Means the number of molecules dissociated by the number of molecules taken. For example, 10 molecules we taken, 10 molecules are totally dissociated, then that is 100%, nothing but 100% dissociated. So what is the alpha value? That is equal to 1. For example, only 5 molecules, the taken molecules are 10. So in that which are, how many are ionized? Only 5 are ionized, remaining 5 are unionized. Okay, then alpha is equal to 5. 5 are dissociated. What is the taken molecules? 10. That is 0.5. So take for strong acids maximum dissociate అయిపోతుంది. Maximum dissociate అయిపోతుంది, they are near to 1. Not 100% అవ్వకపోవచ్చు, కాబట్టి 1 or near to 1 అంట. 1 కంటే ఎక్కువ ఉండే ఛాయిస్ లేదు, because taken molecules dissociated molecules equal అవుతాయి, there is a maximum capacity, కాబట్టి ఆల్ఫాకి maximum value 1. So 1 ఉంటే 1 or near to 1 ఉంటే that will be the strong acid. If alpha value is very less, for example, for weak acid, generally we know the weak acid hydrogen cyanide, it is a weak acid. Like you say acetic acid, so it is a weak acid. So for this compound generally alpha is so around 0.02. So and for weak acids alpha value is maximum 0.02. Taken molecule dissociated molecules number by taken molecule cheste, for weak acid it is equal or less than 0.02. A very less number of molecules are dissociated, means less number of H plus are formed. Means extent of dissociation, extent of ionization is less, there is a weak acid. If extent of ionization is more, they treat as a strong acids. Okay, the same can be, you can apply the same thing for bases. Okay, so now alpha, now we can write the formula for alpha, that is so in the form of formula we can write that alpha is equal to extent of ionization. So the alpha is equal to number of molecules ionized by number of molecules taken. This is known as alpha, number of molecules ionized by number of molecules taken. So it is applicable for any chemical compounds, maybe acids, bases, salts, whatever the compound, you can apply this formula. So alpha equal number of molecules ionized by number of molecules taken. Okay, now we apply this for this acid equilibrium and base equilibrium. Okay, so if you write this, now we apply it for separately for acids and bases. Next here one more important already we said there. What is the difference between alpha and degree of ionization? Means there is a very slight difference in terms of number. In terms of number of molecules explained చేస్తే that is called extent of ionization. In terms of percentage చేస్తే that is called degree of ionization or percentage of ionization. Means what is the percentage of ionization? What is the degree of ionization? Means just that is into 100. So it is an important point. Degree of ionization or percentage of ionization equal nothing but alpha into 100. So this remember it as a important formula. Okay, degree of ionization or nothing but percentage of ionization is alpha into 100. So alpha means extent of ionization. Okay, now we apply this for acid and base dissociations. Now we apply it for acids. What is the acids equation? We know that Ha equilibrium gives rise H plus A minus. So again we apply the equilibrium concentrations. Okay, at first take the concentration. What is the initial? Means before the ionization, take it is concentration is 1C. Okay, it is 1C. Okay, now here there is no products. We know that we done this type of problems in equilibrium, in chemical equilibrium. Next, what takes place at equilibrium? So at equilibrium, after dissociation, we can write that is a C. So here generally we write in the problems we written as minus x plus x in the compounds. In the reactants generally we use it to minus x. In the product we use it to write plus x. So it's the general problems. Now we got how much compound is dissociated, how many molecules are dissociated. Now we got the formula that is called alpha to indicate chestam danni. So that's why we are writing 1C kabatti here we can say it is 1 minus alpha. C 1C means C into 1 minus alpha. Here it is alpha, it is alpha. So in terms of concentration, kabatti the word we are using here is C alpha. Just we can write 1 minus alpha. But we have to derive the equation in terms of concentration. Okay, so concentration terms come on equation తీసుకురావాలి కాబట్టి we are writing like this: C into 1 minus alpha, that is C alpha. Okay, so now write the acid dissociation constant, nothing but equilibrium constant. What is the equilibrium constant? Product concentration by reactant concentration. So the acids kabatti we are taking it as acid dissociation constant. So K is equal to H plus concentration A minus, this is the product's concentration, by a reactant concentration Ha. So what is the Cr? This is C alpha by, so what is this one? C into 1 minus alpha. So on the next next we can write C alpha means 1C get cancelled. Here we get acid dissociation constant Ka is equal to C into alpha square by 1 minus alpha. Okay, here one more important alpha means we know the extent of dissociation. This alpha value is highest for strong acids. It is very less for weak acids. Okay, we know for weak acids it's very less, that is less than 0.02. So less than 0.02 kabatti in the denominator we can neglect this 1 minus alpha, because for weak acids alpha is very less kabatti. Okay, very less, therefore 1 minus alpha in the equation can be neglected. So very less value, that is also present in the denominator. So numerator low, very whatever the small value we cannot neglect. It is present in the denominator, that's why we can neglect it. So therefore we can write K is equal C into alpha square. So this will be known as a formula. Okay, from now onwards we have to remember for weak acids. For weak acids we have to follow the dissociation constant of weak acids is Ka is equal C into alpha square. C is a given concentration, alpha extent of ionization. So we can change this formula. There is a what about alpha? So alpha square is equal to Ka by C, and what is alpha? So alpha is equal to root Ka by C. Also remember this is also a formula. Okay, for acids you have to, for weak acids mainly. Strong acids there is no bother, there is exactly for example strong acid HCl, H3S4 like the acids I have to take the direct concentration, because the total concentration can be dissociated. But for example 1m HCl తీసుకుంటే we can take directly 1m H plus and 1m Cl minus. 1m HCl తీసుకుంటే the total dissociated maximum కాబట్టి 1m H plus ఫామ్ అయితే 1m Cl minus ఫామ్ అవుతుంది. సో అప్పుడు మనకు సపరేట్ ఈక్వేషన్ అవసరం లేదు. కానీ ఫర్ వీక్ యాసిడ్స్ ఏంటిది, the degree of dissociation we have to get idea. అంటే in the problems they will give how much percentage is dissociated. దాన్ని బేస్ చేసుకొని we have to find the Ka value. Ka is equal to C alpha square. Means if Ka is highest, Ka value highest ఉందంటే what is the meaning? Ka value highest means the numerator is highest. Okay, Ka value highest means numerator is highest. Numerator highest means the H plus concentration is highest. Means in some questions Ka values will be given, మనం దాంట్లో ఫైండ్ అవుట్ చేయాల్సింది ఏంటంటే విచ్ ఈజ్ స్ట్రాంగ్ యాసిడ్, విచ్ ఈజ్ అ వీక్ యాసిడ్. సో ఆటోమేటిక్గా ద స్ట్రెంత్ ఆఫ్ యాసిడ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు Ka. Ka వాల్యూ ఎక్కువ ఉంటే సో న్యూమరేటర్ ఎక్కువ ఉన్నట్టు, ఇక్కడ న్యూమరేటర్ ఎక్కువ ఉందంటే అది బట్ ఫార్ములా H ప్లస్ ఈజ్ మోర్, కాబట్టి స్ట్రెంత్ ఆఫ్ యాసిడ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు K, acid dissociation constant. So therefore here we can write the strength of acids directly proportional to Ka. Okay, because the ionization strength at the Ka value highest, that is nothing but equal to strong acid. So in the same, we have another formula, that is alpha equal to root Ka by C. Then again, what is the relation between, if alpha is highest means that is a strong acid, means the degree of ionization is, degree of ionization or extent of ionization, whatever it is, that is also directly proportional to root A. Okay, means we can write extent of ionization, or we can write it as a percentage about a degree of ionization. So both are similar concept, is directly proportional to root K. So we have to remember this also as a formulas. So next, so once again see the acid reaction, we get the some more formulas. So H gives H plus A minus, and we know that K is equal to H plus A minus H. So here we are writing H plus equal, directly we are writing H plus, and A minus in the place of A minus also we are writing H plus, because the concentrations are same. The concentration of H plus A minus are equal kabatti. So 1 mole of A plus 1 mole of A minus undi, 1 mole of H plus undi. So we can write H plus in the place of A minus. Okay, the concentration of A minus equal to H plus, means since we are writing A minus concentration, we are taking it as H plus, and we are taking the concentration of the reactant, nothing but acid, in terms of C. So we can write that is H plus into H plus by C, that is equal to H plus square by C. So here we got so equalize on these two, the Ka is equal to H plus square by C. So now you can write some more formulas based on this. So what is the H plus square according to this equation? The H plus square equal to K into C. K into C. So C is a concentration, K is a dissociation constant. So these are mainly useful in the further problems. These are very important to calculate the acid strength problems and base strength problems. Okay, here H plus concentration is Ka into C. Just if you want to get only H plus is equal to root Ka into C, you have to remember it. So H plus is equal to root Ka into C. Just remember, these are mainly applicable for weak acids only. Strong acids ki H plus ante direct ga acid concentration తీసుకుంటాం. Already we said 1m HCl ఉంటాయి. Then what is the hydrogen ion concentration? 1m. What is the Cl minus concentration? 1m. Means అక్కడ total alpha is equal near 1 కాబట్టి, అంటే total dissociate అయిపోతుంది కాబట్టి we can write directly the concentration. For weak acids లో difference వస్తుంది. Weak acids మళ్ళీ దేనిపైన డిపెండ్ అవుతుంది? ఆల్ఫా పైన డిపెండ్ అవుతుంది. So if you know the Ka value, so you can write the H plus equal root Ka into C. If it is given in terms of alpha, if the information is in terms of alpha, so already we know that Ka is equal to, by applying, we know that Ka is equal to C into alpha square. By applying that here, we can get H plus is equal to root of, in the place of Ka we can write C alpha square. C alpha square, again C is there, so totally C square alpha square. C square alpha square means C alpha whole square, that is root. C alpha square root get cancelled, becomes only C alpha. So therefore we can write H plus is equal to C into alpha. Means if it is given in terms of Ka, so we can write H plus equal root Ka into C. If it is given in terms of dissociation, we can write H plus is equal C into alpha. Okay, these are the main formulas. Are alpha also we can calculate with the help of H plus by C. So you have to write the formulas at one place. Okay, we are giving the derivation, so to understand the formulas easily. Okay, now we apply the same concept for bases. This is called dissociation, nothing but ionization of bases. Okay, for bases, what we read the common reaction BOH and giving rise B plus plus OH minus. And what is the dissociation? Sorry, what is the equilibrium constant for it? It's a base, that's why we are writing Kb, equilibrium constant, or it is a dissociation reaction, that's why we can say base dissociation constant. So BOH. So again, so Kb is equal to, we can write it's C into alpha, C into alpha. Here C into 1 minus alpha, exactly acid derivation system, adhe model though, there is no change in it. So we can write, so here again, we applied for weak bases. So strong bases ki no problem. So weak bases kosme we are applying, we are giving this formulas. So for weak bases we can write, for weak bases alpha is very less. Alpha is very less. So 1 minus alpha, 1 minus alpha in the above equation is neglected. So after neglecting that 1 minus alpha, we can write Kb is equal to C alpha squares. Okay. So that can be taken as a general formula, that Kb is equal to C into alpha square. Okay. So next again we apply this Kb value. Okay, with the help of say it is equation 1. So now take the B plus concentration. Take the B plus concentration is equal to OH minus concentration, because both are 1 mole kabatti ikkada the concentration of OH minus is exactly equal to the concentration of B plus. So and take the initial concentration of the base is C. So by applying in equation 1, we will get Kb is equal to, here this is taking B plus, in the place of B plus we are writing OH minus. OH minus concentration by C. So the Kb is equal to OH minus square by C. So therefore OH minus directly OH minus is equal to, we can write Kb into C. Now, so here also we can change, that is alpha square is equal to same Kb by C. And what is alpha? Alpha is equal to root Kb by C. Means exactly similar to the acids. The strength of acid directly proportional to Ka. Here also strength of the base is directly proportional to Kb. Okay. So therefore here we can write what we got the formula, that OH minus equal to root KB into C. Already we know that KB is equal to what? KB is equal to C. Alpha square implies the OH minus is equal to root C into alpha whole square. So finally we got OH minus is equal to, it will cancel, C into alpha, and alpha is equal to C by OH minus. Here important what is the, already we know the square brackets. The square brackets indicates about the concentration. So what is about the C means? The C means the concentration of acid or the concentration of base. Here we are discussing about base kabatti, the concentration of base. What is OH minus concentration means? So after dissociation, the total acid is dissociate kaadu. Some acid and some base gaan dissociate avutadi. Dissociate in the form and concentration, that is OH minus concentration. It is the acid concentration. If both concentrations are equal, already the first strong acid, strong bases, we know that acid concentration equal to H plus concentration. A base concentration is nothing but OH minus concentration. And a strong acid ki strong base is formula apply cheste, we will get alpha equal to 1. Okay, that's why these formulas we have to use in the problems where the weak acids are taken. Okay, so finally here we can write strength of a base directly proportional to Kb, means Kb decreases, strength also decreases. Next, extent of ionization or degree of ionization is proportional to root Kb. For bases it is root Kb, for acids it is root Ka. So generally we can write some points here. For strong acids, the concentration of H plus is nothing but equal to the concentration of acid, then no change. Same for strong bases. The OH minus concentration is equal to the concentration of the base. Okay, for weak acids only we have to take the H plus. The H plus is equal to C into alpha. Okay. For weak acids, H plus equal to, we have to say K into C. Root K into C, and in terms of alpha, there is C into alpha. Means for weak acids 100% dissociate avagabdi, we also have to consider the alpha value. Okay, if alpha is not given, directly we can take the alpha equal to 1 and H plus equals C. For weak bases, the OH minus equal to again C into alpha. Okay, so these are the main formulas in the degree of ionization. So have to understood very perfectly to this, because it is going to be very important role in the calculating the next problems. Okay, so in formulas kotta meeru oka daggara rayandi. So already we got the different formulas at different sites. Kabatti final ga meer note and rasi, so formulas మొత్తం ఒక దగ్గర గ్యాదర్ చేయండి. Okay.